for Guava.
Hello, hello. We are Guava. We are the Genomic User Accessible Variant Annotation API. I'm Ruth. This is Melissa. This is Mitch. And we also had Ron Amar, who is with us. So we are the first scalable, secure, open source, and free API that allows clinicians to upload the genomic variations of their patients, find out what genes they affect, and decide on a diagnosis. So here's Mitch to tell you about some of the specs.
All right. So can you hear me if I just talk from here so I can use the computer?
There you go.
Oh, awesome. Thank you. So right here in front of you, you can sort of see it's a little blurry, but this is a VCF document. So this contains all the data about a particular patient's genome. Unfortunately, as you can see, it's quite messy, and there's not much you can do with it in that form. Furthermore, that's just looking at the genes themselves. So what we do is the clinics or the hospital have this file, they upload it to us, and then we go through an annotation pipeline which annotates all the genes in the genome, and that data might be something like 100,000 to 1 million rows in a database. And that's incredibly difficult to find anything useful out of because only 0.01% might actually really mean something significant to the patient. So from that data, we annotate it, and we get an output like this, which you can't really see, but it's JSON, and that means that any of our clients can then use that, and all of it is annotated particularly for different traits of different alleles in the genome. The benefit of all of this is that I'm not sure if I can focus this. Let's see. Yeah, I'm not sure if it's going to focus, but we have a bunch of different search queries that we can do on this data. So, for example, the one that's right here is finding all the variants in the genes that are less than 0.01%, and that's incredibly important because that shows that these genes are infrequent in the population, which means that there might be something wrong with the patient, so we can look at their disease. We also do a number of other different types of queries, and one of the most important ones, we can cross-reference our entire database with a database on HPO, and that is the Human Phenotype Ontology, and that allows us to look at particular phenotypes, so particular diseases that a patient might have, and it gives us all the genes that we need to look at in order to really make a diagnosis on that patient. So by cross-referencing with that database, we can look up there, then look at their genome, and see if it looks like they might be susceptible to something like breast cancer. And this entire API works so that even though we have something like 100,000 rows right now for this particular patient, we can do these queries in under 100 milliseconds, which is really great, and something in the way they're doing it right now with the software that's out there, they're unable to do it with that speed. And furthermore, now we can take all these genomes of lots of patients, store them all in our database in the cloud, so a hospital doesn't need to maintain their own servers, and we have a key-based authentication system in order to keep this secure so that any clinic can have a project so that clinicians working there only have access to a certain number of these patients, and all the information is de-identified, so even more so you can feel safe if your information is now stored in the cloud. And then for an example, we also developed a little user interface, and the user interface, if this is going to load right, shows you the way that a client could develop software on top of this API in order to, oh, it's not loading right now, but in order to visualize this data and have it come out really effective for them so that they can use this in the clinic. So,
Let's give it up for Guava. With all their technical challenges, they finally got the presenter to work.